3.18 grams per cubic centimeter versus crust, continental crust, about 2.9 grams per cubic centimeter. Not a big difference, is it? But it's enough. So I can almost pretty much figure out that's what's going to happen. Whereas when I have two oceanic plates collide, like I'm seeing in Japan, well, I've got two oceanic plates. They're the same, about 3.18 grams per cubic centimeter. So which plate is the one that's going to subduct? Which one was it in the battle between the continental plate and the oceanic plate? It was the oceanic plate, and why? Because it was the denser, right? It had more mass per unit volume than the granite. So isn't that same principle going to work here? Isn't it going to be the denser of the two plates that's going to subduct? So why would I have different densities in these plates? They're both oceanic plates. How am I going to make one denser than the other? Temperature. Which one would be the denser? Warmer one or the hot or the colder one? The colder one, yeah. If I'm here at the spreading ridge, that's a warm spot, isn't it? As I move away, it's getting colder. But what's happening to the rock? I've got a ridge right at the spreading center, and as I move away, what happens to that ridge? It kind of disappears, doesn't it? And anything sitting on that ridge subsides because that ridge is cooling off, shrinking, contracting. That means it's becoming denser. So when I get to a battle here of two oceanic plates, the one that's going to subduct is the denser one, and that means it's going to be the colder one that's had more time to cool off and become denser. So it's the colder, older one. Okay, see how that all fits together? Okay, everybody's ready to leave, and we still have 2 more minutes. Okay, we'll finish this section up, and then you can all. What happens if I have 2 continental plates come together? Continental ocean plate, I had 2 ocean plates. What if I have 2 continental plates? Both granite, both really light. Neither one is going to have much density difference because they're both just colder than the dickens. They're already both about the same temperature, about the same density. Neither one of them is going to want to subduct. So instead, it's like a big front car crash. They just smash into each other, and they just kind of build into the air. So now what I end up seeing is a whole different style, and what I'm going to get there is going to be, what I'm going to get here now, no subduction. That means no crust going down and remelting and turning into igneous rock. Now I've just got all sorts of pressure as these two things plow into each other. I've got some temperature increase due to the increased pressure, increased temperature, but for the most part now what I'm going to see is I'm going to make metamorphic rocks, not igneous rocks. I'm going to change the rocks due to heat and pressure, not remelt them and make new igneous rock. So I get a whole different style here. I get mountains and I get metamorphic rocks instead of volcanoes and igneous rocks and mountain ranges or island arc systems that I get with the other types of conversions. Okay.